Okay. As you can see, my name is Peter. Um, I'm studying informatics or computer science and Belgrade Faculty of Mathematics, and I'm the member of Hack Lab Belgrade. Also, I'm writing for Libre magazine. That's magazine about free libre open source software, and I'm writing mostly about encryption, privacy, security stuff, online and offline. Okay. So this talk is going to be about a few things about passwords and passphrases. So the differences between, and also what is better, right? Measuring password strength, how the password and passphrase strength are actually measured, and how servers like Google, Facebook, whatever, handle users' passwords in a secure way. Mostly of them don't handle the properly, and I say when the database of your server or service online gets hacked, you need some way to protect your users' passwords and send them mail to change everything and stuff like that. So then we'll get over how passwords are actually hacked, some attacks on users' passwords by phishing, brute force, or social engineering, and at the end there will be a method, alternative methods of passwords, alternative methods of authentication on websites rather than passwords and passphrases. So, what's wrong with my password? Right. Most of the users think that 8-character password or something like that will be enough to protect them. And if they changed, I don't know, S with this dollar symbol, or O with the 0, or A with 4, that will make their that will make their password more stronger, but that's not the true in most cases, because attackers also know these methods, and they'll kind of try these combinations for your password too. Passwords have another bad how to say, property, that they are harder to remember, as your password get more complex and has more random characters in it. It is more and more harder to remember it, and then you're forced to use some, I don't know, password managers, or to write them down. You can't remember all your different passwords. They are complex for about 26 or 27 websites, right? You can't hold it data in your head, right? And if you're not doing the passwords right, if you're not generating them randomly, then you're susceptible to social engineering attacks through guessing. If the attacker knows you, knows your interests, job, what you do, what you like, hobby, they can then easily guess your password if you make your passwords looking in your room, looking around, or making from the words or symbols from your job or hobby, right? So make your passwords more unique and random, something that's not related to you in any way, right? Another thing is that the people, we are humans, are not very good at creating anything random. So we are species of patterns, and we use some patterns to remember passwords or to create them, and that's not very good when it comes to cracking, right? Cracking passwords in all ways. And yeah, it's hard to remember those of the different nonsense passwords with numbers, special characters, and all that. You may saw that on internet there was a TED talk by Lorrie Faith Cranor. She made this password security blanket that has top 1,000 most used passwords in the world. So I love you, like 1, 2, 3, 4, 5, 6, 8, 7, 9, or something like that. The size of the passwords is how frequently the passwords is find. How frequently password can be found on various websites. So another thing, this is top 25 passwords, right? Another thing when you're studying a password is that it's very hard to obtain true database of users' password. You can't just go to the sysadmin and say, hey, give me your user's passwords, right? He won't give you. Nobody will give you. So you're stuck with the hacks that happens all the time on the internet, like Ashley Madison or Sonic hacks or whatever. Whenever someone some service gets hacked on the internet, the hackers dump the database on the internet or Pirate Bay or wherever, and you have that database to study, right? But that's not good because you can be sure that they didn't tamper with that database and that database is actually true and original, the real one. So there are many problems when you're studying the passwords. It's not easy to get to real one of users, right? So what's passphrase? Many of you might also already know the passphrase is just a phrase. It has words from the dictionary, somehow ordered in it. It doesn't need to be word from any dictionary, right? It can also contain few passwords randomly selected in any order. And there is a question, what are good and secure passphrases? So, and how to create them, how to generate them. So we'll get back to this in a minute. And what we said previously is that people are not good in creating random things at all. So the same applies for the password and passphrases. So if you can, find some software online that can generate random passwords or passphrases, whatever. You can use the good open source software like KeePass or KeePass6. Try to use the open source software, not the closed source one, because you can trust them, right? And then that's one quiz. Can you actually guess what's the good passphrase and what's the bad one? What's the most secure and what passphrases are not secure? I'll give you a second to think and then there will be an answer. So there are random passwords. Some of them are random, some of them are generated by humans, some of them are generated by computer, some of them are from the internet. And that's the correct answer. So, as we can see, passphrase 1, passphrase 2, passphrase 3 is not so random and not so secure, right? Even though it has numbers and letters and it's long, very long, it's not secure because it's not random. We'll get to how to measure password strength a little bit later. And my passphrase is hard to guess is not very hard to guess, right? Because it's sentence, it's not random. The humans created the sentence. And if you know the human who created them, you use some social engineering attacks and you get to know his password, right? Correct horse petal is staple. You already know this one. That's from XKCD.
Everybody has it in every database.
Yeah, that means that every passphrase you see anywhere in the web is not so secure because it has been on it. From then on, it's in every database for hackers. So you need to create your password by yourself and try to do it as more random as you can. Yeti permanent kilobyte Visa skin. It is the password generated by my computer. It's random. So it just so happens that this password came out. Red Cross, healthy, pharmacy, medicine. Why is this not good? Does anybody know? What? Yes. So you can see that you can actually guess that the person who created this password, all these words has a similar meaning, and if the person who created the password has something to do with medicine or pharmacy or whatever. And similar is police, gun, cuffs, undercover, chief, and red, green, blue, sky, magenta, yellow are also not good because all the words are from the same kind of stuff, right? Passphrase advantages. So easier to create, maybe not because we're not so good at creating random anything, and you should stick to programs that are meant for creating random things. But if you're in this stuff, you can actually learn to create stuff that are more random, right? Definitely easier to remember than password. You already remember half of the passwords that were on previous sites, right? Slide, sorry. No need to writing down. As I said, you already remembered. And hard to automate attacks. Because, as you can see, verb, adjective, noun in these passphrases, there is no order. When you see verb and then you don't know what actually next is going to be, adjective or noun or whatever. It is random. There is no any rule of what is going after what or before what. So if created random, it needs to be brute force, right? And are they more secure? Maybe because they are passphrases and they can be longer, but still people will be able to remember them, then they are more secure. If you create passphrase that has 2 words and every word has 2 letters, that won't be some secure passphrase, but it will be more secure than I don't know, 3 or 4 characters password. So you maybe heard of this thing, Diceware. It is a method of creating passphrases. You just need a Diceware word list. It has 707,076 words. You need 1 dice and paper and pen, and you just throwing a dice. The number that you throw the dice represents some word, and you collecting those words and you generate the passphrase. This is for real paranoid ones, because there were talks and people wrote about Intel compromising pseudo-random number generator in their processor for creating encryption keys, dual elliptic curves or something like that, for creating RSA keys for public and private encryption. If you heard about that, that's the stories. I won't comment the story much more. Yeah. So you have a link where you can get the Diceware word list if you want to play with it. And we are here at entropy. So how password strength are measured? It's a little bit of math, right? So you have a character set. For example, if you use, I don't know, 8 characters, and your character set is all lowercase letters or uppercase letters, all numbers, and use all available 32 characters, special characters on your keyboard, not using the space bar, okay, just characters. Then it all ends up at 94. So you have 8 characters. Any character can be any of these 84. So you have 8 places where you have 84 possible things, and you set the 94 to the power of 8 and do the logarithm on the base 2 of that, because computers work only in binary things, right? And this long number here, this long number, okay, here, this long number here represents all the possibilities for 8-character password. If use the character set of all 94 available. And when you do the calculation and do the math and get the logarithm on the base 2 of this number, it is 52. So that means that any password that has 8 characters and has some of all these, at least one of all these possible lowercase letter, uppercase letters, digits, and special characters, it will be 52-bit entropy. That will be its strength, right? We'll talk a little bit later what's the minimum entropy for your password. And when we are here for passphrases, the calculation is similar. You're not using character set is the word list. So if you're using some vocabulary, your vocabulary can have about, I don't know, 20,000 words, and that's your character set. And password length is actually how many words you use from that character set or vocabulary. And you do the similar calculation, and if you're creating 4-word passphrase from out of 20,000 word dictionary, it is about 57-bit password strength for 4-word passphrase. So yes, this is an example. So any 4-word passphrase chosen from randomly from 20,000 words has more entropy than any 8-character password. So it's more stronger. And Yeti Permut's kilobyte visas is easy to remember and much stronger password. You can see that there is no special characters, there is no uppercase letters, there is no numbers, but it is still stronger passphrase. Okay, I did a lot of calculations like this with logarithms and powers, and got to this chart, right? You can see that you need at least 80-bit entropy for a strong password or strong passphrase. This means that if you're looking blue curve here, you need at least 13 characters in your password, and for passphrases, if you're using, let's say, Diceware, that's the green one, you'll need about 7 words. So 7 words passphrase chosen from Diceware, it's a very small dictionary, though, has the same strength as 30-bit password. And if you're using a very long dictionary and for creating passphrases, that's the yellow one, you'll need approximately only 5 words. So for passphrases, it all depends how big your dictionary is when choosing the random words. Yes, this is the famous XKCD. It actually quite good explains what we just talked about, even though the math behind on the middle slides is not good. Correct horse battery is stable for random common words. On contrary, you have a password that has 13 characters. Yeah, it has numbers, uppercase letter, down, lowercase letters, special characters like and he replaced A for 4 and O with 0 and stuff like that. But then if you didn't remember this password right, if you didn't write it down, and it is easy to forget your password because you didn't switch all O letters with zeros, and you can easily forget what actually you did, and your password is not that strong as correct horse battery stable, which the comic actually said at the end of this comic. You actually remembered the correct horse battery stable, right? But you didn't remember the password. And it said throughout 20 years of effort, we successfully trained everyone to use passwords that are hard for humans to remember, but easy for computers to guess. Yes. So I found some online password strength measures and strength calculators, right? And the measure, you can see I chose only upper or only lowercase letters for password length of 18 characters. And it gives you 84 bits. So anything above 80 bits is, you can say, very secure, right? You'll need 9 years to crack it. And the good advice is if you're using passphrases or passwords, whatever, change it once in a year, right? Computers do get better and faster every year, and your password or passphrase will be cracked sooner or later. So yeah, password done right. If you still don't want to stick to passwords, don't want to change to passphrases, as I said, use some open source software like KeePass or KeePass6. It is a good program for actually creating the random passwords and passphrases. It encrypts all your passwords with one, very secure one. And make sure when you're choosing how many bits it is about 80. Change them often, and when you're at public Wi-Fi, like here at BalCCon, use some layer of encryption, right? VPN or Tor will do good, right? So how servers actually handle the user's password? They do something called hashing. And hashing is similar to encryption, but it doesn't use any key. So the key for your data is your data itself. It pulls the data, it goes through some function, and you have some output. And the good property, or the bad one, about a hashing function is no matter how big your file is, it can be gigabytes long. If you change 1 bit in a huge file, the hash output will be totally different. So whenever something is changed, the hash file is totally different. It doesn't look anything like a previous one. And they just use site says, okay, log in, tell me your password, you enter the password, it hashes the password and puts the hashed password in the database. When you log in later, say log in again, okay, tell me your password, it doesn't keep your password, but it keeps the hash function of your password. And it does the calculation of password. Pulls it through the hash function. If the hash that has been in the database matches with the new calculated one, the site will let you log in, right? That wasn't so secure because people figured that out, and when you're using a fast hashing function like MD5 or SHA-1 that are broken, 5 years ago, people actually build tables of hashes. So they say AAA will be that hash, BBB will be that hash, CCC will be that hash, hello will be that hash, password will be that hash, password1 will be that hash, and build all the table. When they hack the website and get all your hashes, they just have to match the hashes they have in their rainbow table and to see what's your password. Then people got to this idea of salting, and salting is just adding some string to the end or to the beginning of your actual password. So it can be something added before or after your password, and then when that salt gets added to your password, it is hashed through the hash function and then stored. This is done because the same passwords have the same hash. And if you hack the website and have and get the old hashed password, and you see the most common hash will be most probably the most common password used. And if you know the most common password is 12345, then you actually broke that database of hashes. And when you do something like salting, you're making the same password look different if choosing salt differently for every password. So don't use the same salt for every password. Change the salt for every user when you want to hash it. And yeah, we already said everything like that, but let me mention bcrypt. Bcrypt is hashing function, newer one, that is slower and more secure than MD5 and SHA-1. Don't use broken hashing algorithms like MD4 and MD5 or SHA-1. You can look it up on the Wikipedia and find how they are broken. And we said generate new random salt for every user. Don't reuse the salt. This is advice for website admins, right? If you handle some user database and their password, this is the advice. You may heard about Ashley Madison hack. They used very slow hashing algorithms like bcrypt. They did all right. Every security tip that I mentioned here, they get it right, but they still got hacked. And what's even more interesting, that 11 million passwords are cracked in just 10 days. How is this done? Well, some of the admin logins for the website use MD5 hash, and that MD5 hash has also the same salt for every bcrypt hashed password. And the people who got the dump of the hack figured it out, and they were able to crack some of the passwords, not all. So the bad thing that Ashley Madison did is they reuse the same hash, the same salt for every password, and then that's statically hashed. Password cracking. Okay. It can be cracked through CPU, it can be cracked through GPU, or new Bitcoin ASIC miners. The Bitcoin ASIC miners are made especially to crack SHA-256 hashes. It is specialized hardware, and graphic cards can crack any type of hash. Phishing. This is interesting because people who don't know what phishing is most often get to be hacked with something like this. Well, attacker actually sets up his own version of I don't know, your bank website, and if you don't check the URL, you can actually enter the password, your actual password for your bank, to his site, and then he got your password. That's the user's fault, not the server. Yes, that's another XKCD comic for social engineering. Let's say something about two-factor authentication. That's a new method that Google uses. Many other companies also use Google Authenticator to authenticate users when they log into some websites. It is more secure. They're using just a password, whether you're hashing it or salting it or not. Because if your database gets hacked and someone gets all your hashed password, he cannot log in unless he has some newly and randomly generated code that is sent to your mobile. Only if he has your mobile, then he can log in to site. There are YubiKeys that are hardware. They are hardware USB keys that have built in some keys, whether they're public key encryption or not. And you can log in only if you have that physical USB. Facial recognition and fingerprints. Yeah, there's some statement for Crick Skaugen that worked for Intel. Intel new core generation of processor combined with some of their proprietary software has the ability to log in users based on their faces or eyes or whatever. And you have something like fingerprint verification on your iPhone. That's something that's new and alternative to password and passphrases. But as this comic said, this is not the good solution, right? At the end of the day, it's still you. If someone kidnaps you or hijacks you, he tortures you and he got the password, right? So they are talking here about 496-bit RSA keys that are public and private key encryption. Now you can use it to encrypt your whole hard disk if you didn't try it. There is an interesting talk, and the research paper has been released on the topic hashing is dead, long live the password. New idea that helps the sysadmins who run some service, web service, and when they have a problem of storing the passwords, they come up with the idea of having a very large file at the server I mean 1 terabyte or 2 terabyte large file that is a secret, randomly generated file that actually is part of authentication method. So if the hacker doesn't have this file, then he can access any database or login. And that's about it. Any questions? Okay.
You mentioned online sites that can generate passphrases. How secure is that?
That is not secure, and people should not use anything from any website as to password or passphrase for their secret things, right? Anything you find on any website that has, hey, you can use this password or passphrases to secure your things. Hey, it's very long. That's not good because everybody else also have that password or passphrase in the database. The sites that generate passwords, where they are not secure because you don't know how they generate your password, right? The algorithms is on the server side and you don't audit that, right? So don't use that. Okay? Question? Okay.
Maybe you could say again, does salting really help? Or does it only help with rainbow tables, but rainbow tables are not the most important attack today?
Salting helps if done properly. Do not reuse the salt. Generate the new random salt for every user, and then you can actually store that new generated salt alongside with the hashed thing. When you have user password and newly generated random salt that gets fed into hash algorithm produces some hash, and you then store in your database that hash and that random salt you generated. So that is secure.
But then if like the database gets leaked,
Yes.
the attackers will have the hash, but they will also have the salt, right?
Yes, but then they'll need to apply the rainbow table attacks for every user differently. Every user will have different salt. So it is something that in a way stops automated attacks. It is not purely secure, right? So use the hash algorithm that is slow, like bcrypt. Don't use the MD5 that are fast and broken.
Thanks.
Okay?
But isn't it better to use a hash with salt, which you actually generate via some proprietary algorithm? You have like some user's input,
Okay.
which is always the same, like let's say a username, you take the username and then generate the salt from that via some proprietary algorithm, and then you have always that algorithm when you're trying to check, so you don't have to store the salt, and the salt is different for every user.
Okay.
I think that's like a better solution.
That is a better solution, but don't use proprietary things. Anything that can't be audited, it is not so secure.
Not proprietary, but only on server side. On the thing that you only know, the algorithm.
Okay. Yes, but as we saw with Ashley Madison hack, they had the secret hash for each, the same secret hash for each user password. And it got discovered, right? So anytime you want to hide something, it's not good, in a way. Because when something that you're hiding gets found, your whole database is breached. It is better, but not 100% secure, right? Nothing is 100% secure. Okay? Another question? Yeah, air-gapped computers, right. But there are attacks with yeah, okay, okay. That's the different topic. Okay. No questions? Okay.
If we get hash of some password or passphrase, how can we know which algorithm was used?
It can be, I don't know actually, but I think the size of the hash that you get actually can tell you what algorithms you use. If you use MD5, it will be a smaller hash. If you use SHA-212, it will be a much larger hash. So it depends on the hash length itself. Okay. If no more questions, then we're done. Thank you.